Now we will talk about the transition and transitional types. As we say, both of them its affect the time in the time of our events. So let's see how they can affect the time intervals. So actually, you can see there is a delay transition and enable transition. So sometimes if you have, for example, you see this location A0 and B0. So here we have invariance. We have an invariance here and we have also an invariance here. So this will delay the transition. Will not go direct to next transition. And here also the second point here we have here y less than 6 and y less than 4. So that's mean we cannot say, and this is actually is these two location should move simultaneously. So if we stay, for example, 6 units of time, that's mean we are violate the rule of this location. Because here we cannot, because here the invariant say we cannot stay more than 5 units of times. So here this one, okay, will delay the times, and then also once we move to the second location, we will use the smallest one. For example, here we have 4 and 6. So because this is, you can stay, for example, one unit, 2 unit, 3 until 6. Here we can stay 1 or 2 until 4. So since we have here the 6 is greater than 4, so we will take the 4. So if you are here now in location A1, A0, B0, then once you move to the location A1, so once you move to the second location, so the time, the y will be 6 or 4 will be 4. Since as we say, we take the smallest one. If we take the 6, so that means we are violate the rule of the second locations. So here we see if x is 0 and y and n also, we have three variables x, y, n. So in the next location, x and y should change to 4, 4, not to 6, 6. If we have only this time automata, maybe the time will change to 6, but here the time will change to 4, take the smallest one. So here what we mean by delay. So we'll delay our times and then we'll delay based on the lowest time. The second one, actually, if we don't have any problem, so we just proceed, for example, from from A0 to B0, if there is no problem. So I mean there is no delay. So the time in the second location will be, if for example if x3 and y3, so the second location will be 0, 0, because here we have actually reset. I mean this is, I mean, if you consider there is no condition here, once we run this location, that means x will become 0 and y 0 and n is 5. So the second factors that affect their time is the organ location. If we have two, if we have an organ location, so the time will not be affected, or we can say the time is decreasing. And for example, if we are in the location A0 and B0, and then x is equal to 3 and y equal to 3, and we synchronize, then for the next location the time will be same. The time will be same unless we change the time. So here an example, if we have two locations. I mean, here we have location 1, location 2, location. Here we have this with organ location. Organ location. So this one will be taken. This one will be taken, and the same time also the time will not be calculated or cannot be increased. Also, the commit location affects the time. So in commit location, there is no delay at the time, and any action transition must be taken. So example here, if we are in the state A1, B1, since A1, B1 is commit location. So you see here, we are in this commit location. So the next state, which is B2, A2, B2, the time will be 0, 0. If the time here 0, 0, and before we leave this location is 0, 0. So the next location will be the same 0, will not be affected. Here just only the increase the n. Increase the. So here as we see we have also the delay. The delay, if we have a condition in the location, we have the organ channel, we have also the commit location. All of them is effective times, and some of them will not. The time will be increasing and will not increase.